Hello again, folks. Mr. Long here. Now, in this video, we're going to do what's called a right Riemann sum. So Riemann's it's the name of the person that developed this procedure, this algorithm, and a right sum just means that we're going to get the y values for each rectangle at the right side of each triangle. Okay, so if you look at this, again, what are we doing here? We're figuring out, and you might want to see an earlier video 1 in this series to get an idea of background and things, but we're trying to use, so we've been given that formula, which you know is area under the curve, right? You know that, between x equals 0 and x equals 6 under the curve f at x. In this case, it's y equals x squared. Now it says we're going to do 3 subintervals using a right-hand sum. So n represents the number of rectangles, which is the number of intervals. That's 3. That's a there, and that's b. So the total width over which I'm doing that is b minus a, and that represents 6. And then that means delta x, the width of each rectangle is 3 rectangles goes into a total width of 6 2 times. So the width of each rectangle is going to be 2. So again, I draw from 0 to 2 is going to be the first rectangle, the second rectangle will be 2 to 4, and the third rectangle will be 4 to 6. Now this time we're doing a right-sided interval, a right-sided sum. That means I take the y value off the right side of the interval. I find this much easier to do on a table than I do on a graph. I always do the table first and then move to the graph. So again, my first box goes from, or rectangle goes from 0 to 2. Well, what's the right side of that interval? X equals 2, y equals 4. The second one is from x equals 2 to x equals 4. What's the right side of that interval? The ordered pair of 4 and 16. The third rectangle goes from 4 to 6. What's the right side of that interval? 6 and 36. At this point, you could go up and draw your rectangles. Okay, so the first rectangle goes from 0 to 2, but the y value is found on the curve at the right side of that. Okay, so there's that first rectangle there. We'll call that A1. And then the second rectangle is, again, I go right to x equals 4, and I go up to y equals 16. Okay, that's the second rectangle. Okay, that represents A2. And then the third rectangle goes from x equals 4 all the way to x equals 6. But where do I get the y value? On the right side of that rectangle, so way up here. Okay, so that's A3. By the way, in the first one, if you noticed, it was an underrepresentation. Well, in the second one, is this going to be too much? Is the error going to be an overestimate or an underestimate? And why? Okay, I want you to think through that, right? Why is it an overestimate or an underestimate? Using the right-hand rule. And would it be true, or right-hand sum, and would it be true if it was a decreasing function, right? Those sorts of things. So to me, it looks like I've got a lot of extra area right now that I don't really have under the curve. So there's certainly some error there. Okay, so how do I go about doing this calculation? Well, I know that the width of each rectangle, A1, A2, and A3 are the 3 rectangles, is 2. So 2, 2, and 2, right? Then I need to figure out the height. Well, what's the height? The height is the height. It's the y value, right? As remember, the area is delta x multiplied by the height, which is f at x, right? So 2 multiplied by, the first one is 4 tall. The second rectangle, which ends at x equals 4, is 16 tall. And the third rectangle ends at x equals 6, which is 36 tall. So again, I calculate that out. 2 times 4 is 8, 2 times 16 is 32, 2 times 36 is 72. Add that up, and that's my estimate for the total area under the curve between x equals 0 and x equals 6. Okay, it's a right-handed Riemann sum. You should total that up so that you can have a total for each type. Okay, we're gonna end this one here, and we're gonna move on to what's called a centered interval in the next short clip.